So today you can go on Amazon and order a 4 terabyte drive for around $120.
This can hold the equivalent of a 330 million page essay in Microsoft Word. If you wanted to print it out, the cost of the paper alone would cost $3 million. It would weigh the same as 20 fully booked Boeing 737s. And if you stack them up evenly in 3 rows, it would still be taller than the Burj Khalifa, the tallest building in the world. Yeah, this drive can store all of that and still fit in your pocket. But it wasn't always that way.
Even in 2000, 4 terabytes of data would easily cost you $16,000.
But as technology advanced and the machines that built these drives became more precise, hard drives are now magnitudes smaller and cheaper. But how exactly can your data, like millions of your documents, photos, videos, music, fit inside this little box?
Wow, that's a great question.
First, let's talk about what data really is. You know how we have an alphabet that can be combined in infinite different ways to form words? Computers don't have that. Computers speak in binary language, which means they only ever understand 2 states, or for this example, 2 letters. Like, imagine that instead of the English alphabet being A through Z, it was only A and B, and you could only form words with those 2 letters. Our dictionary would look like this. For computer data though, it's often represented as 1s and 0s. You've probably seen those hacker scenes in movies where it's just raining down 1s and 0s. Those scenes are very inaccurate, by the way, of what real quote-unquote hackers or software engineers do. But those 1s and 0s do have a little truth to them. Each individual number in a series is called a bit, and by itself is the smallest unit of data on a computer. Even though it's represented as either 1 or 0, what it really means is either electricity is flowing or electricity is not flowing. The brain of any and every computer is the CPU, aka the central processing unit. Our phones, smartwatches, smart refrigerators, even our friendly home assistant whose name I won't say, has a CPU. At the bottom of these CPUs are billions and billions of these tiny things called transistors.
The transistors in CPUs are actually so tiny that you need a special microscope to see them. So to explain them, we're going to use these bigger transistors as an example.
Transistors are like tiny switches for electricity. If a certain amount of electric current is flowing through it, it opens the switch, which is represented by the number 1. If there's not enough electricity flowing, the switch remains closed, represented by the number 0. Fun fact, transistors are made from silicon, which is why when the San Francisco Bay Area started to become the technology hotspot, it was dubbed Silicon Valley. Bits can be combined in an infinite series, but each series of 8 bits is called a byte. And we're familiar with bytes, right? Megabytes, gigabytes, terabytes. Each prefix is just a multiplier. So 1 kilobyte is equal to 1,000 bytes, and 1 megabyte is equal to 1,000,000 bytes, and so on. You're probably wondering how 8 1s and 0s can mean anything. Okay, so that explanation is gonna require some math, but I promise it will be easy to follow. If each bit can either only be 0 or 1, that means at any given time, each of the 8 bits has 2 options for states to be in. And if that's the case, that means there's 256 different combinations of 1s and 0s that can be created to form 1 byte. If this feels foreign to you, then you'll probably be shocked to know that we count numbers the same way. Computers use a base 2 system, given that they only have 2 numbers to choose from. We, on the other hand, use a base 10 system since we have 10 numbers to choose from. Any number to ever exist will use those numbers. So if bits were base 10, 3 bits would give us 1,000 different combinations, from 0 to 999. And another fun fact, the only reason we use base 10 is because we have 10 fingers. If we had 14 fingers, we would use base 14. Just like how words can have different meanings depending on their context, so can bytes. Take the byte 01000011. If we wanted to convert this to English, it would be a capital C. And we're able to figure this out by using the Unicode encoding standard, which maps bytes to letters. Even though every letter and character in the English language can fit into 1 byte, Unicode can hold up to 4 bytes, which means it can map every character in every language in the world into a series of bits that a computer can understand. Emojis, for instance, are also represented in Unicode. Though while bytes can translate into letters and characters, they can also translate into base 10 numbers. So let's take our example again, that's capital C in Unicode. Since it's base 2, we can assign each bit a power of 2, starting from the right and increasing to the left from there. If none of that made sense, all you need to do is follow this pattern, assigning a 2 to each number and adding an exponent starting from 0 and increasing by 1 until you get to the end. Then multiply the bit number either 1 or 0 with the exponential number. When you add that total up, you get 67. The same process works for our number system, by the way, but instead of base 2, you just use base 10. I'm sure you've noticed that when you use an app or website to change a color, they give you the option to change the RGB values from anything from 0 to 255. This is also based off the fact that 1 byte, aka 8 bits, can store 256 different values. Computer monitors have tiny pixels and each have subpixels with red, blue, and green light that, to the human eye, all blend into one color. So setting all 3 of these sublights to a certain intensity between 0 and 255 can create a combination of 17 million different colors. And even though we're setting the numbers from 0 to 255, the computer recognizes them by their bit value. So when we save images, we're basically just storing a bunch of RGB values in what's known as a bitmap, where each square represents 1 pixel. By the way, the RGB values for the color of the subscribe button is 255,0,0. And if you click it, you'll be able to see the pixel color change in real time. Try it out. So before we get into how so much data is able to be stored on such small devices, the last kind of data we need to talk about is sound. Sound is simply the vibration of air particles moving towards our ear. That can be represented as an analog wave, in this case specifically an audio wave, where the amplitude, ka how loud or quiet a sound is, increases and decreases over time. A computer doesn't understand audio waves though. Computers have what's known as an analog to digital converter, which converts sound from audio waves to ones and zeros. It does so by sampling the amplitude of the audio signal at consistent time intervals.
And like we saw earlier, the numerical amplitude value can be converted into bits. So for each time interval, the converter is sending some combination of ones and zeros to the computer that match the amplitude value. The computer recognizes it as a digital wave. A digital wave only has 2 horizontal axes on its graph, representing 0 and 1. But when the analog to digital converter works correctly, it collects enough samples within a particular time interval that the digital wave can be converted back into an audio wave, which is what happens when we hear sound from our phone or any other device.
Okay, so now we know how words, numbers, images, and sounds are stored as bits. Since we know how images and sounds are stored, that means we also know how videos are stored, since videos are really just a series of images. But now we need to know, how big is a bit in the physical world? The first thing to remember is that a bit represents an action, not the presence of an actual thing. The action is electricity is flowing through the transistor, or electricity is not flowing through the transistor. So modern storage drives instead store mechanisms to create this electricity flow. There are 3 main kinds of storage drives that you've likely used or seen: flash drives, hard drives, and solid state drives. First, we'll talk about hard drives since they're the oldest of the bunch. So they used to be in pretty much all computers and laptops until they were replaced by solid state drives, and we'll talk about why in a minute. But you might have also seen an external hard drive. If you watched my last video, you may remember the term electromagnetism and how it was used to create the telephone. If you didn't see it, all you need to know about electromagnetism is that electricity can be used to make magnets, and magnets can be used to make electricity. Hard drives use electromagnetism to store data. And if you look inside of a hard drive, you'll see a bunch of stuff. But the 2 most important parts that you'll see is the read and write head and the data platter, which continuously spins. You can think of the platter, sometimes called the disk, as a bunch of tiny magnets all stuck together. Depending on the directions of the individual magnets, 2 adjacent magnets can create a really strong magnetic field if they are of opposite poles, since opposite poles attract. Or can create a weak magnetic field if they're of the same pole, since same poles repel. The read and write head can read these magnetic fields, interpreting a strong magnetic field as 1 and a weak magnetic field as 0. It can also write ones and zeros by changing or creating magnetic fields. And because of electromagnetism, these magnetic fields can be converted into pulses of electricity, which can be sent to the transistors of the computer's CPU. The amount of space you need to create these magnetic fields is extremely small. We can fit 1 terabyte of data, that's 1 trillion bytes, in 1 square inch of this disk. That's 83 million documents, 250,000 photos, or 250 movies in this tiny square inch. The weight of the hard drive, even for 5 terabytes, is still less than a pound. All the weight comes from all the other pieces inside the hard drive that make it work. The magnetic fields themselves are weightless. If you're impressed by that though, then you need to hear about flash memory. Unless you live completely off the grid, then you use flash memory all the time. It's used in cell phones, computers, laptops, smartwatches, memory cards, game consoles, even flash drives. Yes, a flash drive is called a flash drive because it uses flash memory. Flash memory is another type of data storage medium. Except, unlike the hard drives that use magnetic fields to represent ones and zeros, it works a little differently. Flash memory contains millions to billions of these tiny charge-trap memory cells that can trap electrons. Quick refresher. Every physical thing in the world, including us, is made up of billions and billions of atoms. An atom has 3 types of subparticles: protons, neutrons, and electrons. Electricity, specifically electric current, is the flow of electrons moving from one atom to another. So, if each charge trap stores 1 bit, the presence of electrons inside the trap is used to represent 0, while an empty charge trap represents 1. This is the basic idea of how they work when they were first created. Most charge traps today can actually store 3 or more bits of data, but the idea that a certain amount of electrons represents a certain combination of bits is the same. So the last storage device we need to talk about is solid-state drives. Most solid-state drives actually use flash memory to store data. And they're called solid-state drives because, unlike hard drives that have a rotating platter and a moving read and write head, solid-state drives have no moving parts. This is one of the main reasons why solid-state drives have replaced hard drives in most devices today. So with all that, we need to address one last thing. When do you choose one over the other? Right now, you can look for the most highly rated storage devices on Amazon and find a 1 terabyte external hard drive for $40, a 1 terabyte flash drive for $80, and a 1 terabyte external solid state drive for $120. Flash drives can last for around 10 years, but they're made with portability being the top priority, which means they're cheaper and smaller, but much slower than solid state drives when it comes to transferring data. Hard drives are also cheaper than solid state drives and sometimes flash drives, which can save money if you don't plan to read and write data too often, because the read and write head of the hard drive can start to wear down over time. Also, because of the moving pieces inside, it can get damaged more easily. Either way though, they still have a lifespan about 3 to 5 years. If you want a quick external drive where you'll constantly be saving your data to and don't mind the higher price, a solid state drive is a better choice. Those usually last around 5 to 10 years. If you enjoyed learning about how data is stored, make sure you check out my last video about how the internet works.